Uranus, the seventh planet from our Sun, is a world of mystery and wonder. It stands out in our solar system for its unique characteristics and enigmatic nature. It is an ice giant, cloaked in a thick atmosphere of hydrogen, helium, and methane. These gases give Uranus its distinct blue-green hue, making it a striking sight in the cosmos. But what truly sets Uranus apart is its unique tilt. Unlike any other planet, Uranus rotates on its side. Imagine a planet tipped on its side, rotating at almost a 90-degree angle. That's Uranus. This extreme tilt is unlike anything else in our solar system. Its poles point towards the sun, while its equator remains in perpetual twilight. This creates a unique environment with unusual lighting conditions. This unusual orientation has fascinated astronomers for centuries, sparking endless theories about its formation. The mystery of Uranus's tilt continues to captivate scientists. Some believe a massive collision early in its history may have knocked Uranus onto its side. This theory suggests a cataclysmic event that dramatically altered its orientation. Others speculate that gravitational interactions with its large moons could be responsible. These interactions might have gradually shifted Uranus's axis over time. The exact cause remains a subject of debate, adding to Uranus's intrigue. Scientists continue to study and discuss the possible reasons behind this phenomenon. Whatever the reason, Uranus's tilted axis creates extreme seasons unlike anything experienced on Earth. These seasons are marked by dramatic changes in sunlight and darkness. Each pole experiences decades of continuous sunlight, followed by decades of complete darkness. This results in a unique and extreme seasonal cycle that is truly fascinating. Uranus is the seventh planet from the Sun, a distant and mysterious world in our solar system. It lies at a vast distance, approximately 1.8 billion miles, or 2.9 billion kilometers from our star, the Sun. At this incredible distance, it takes Uranus 84 Earth years to complete a single orbit around the Sun, making its seasons last over 20 Earth years each. In terms of size, Uranus is the third largest planet in our solar system, after the gas giants Jupiter and Saturn. It has a diameter of about 31,763 miles, or 51,118 kilometers, which is about 4 times the diameter of Earth, making it a truly colossal planet. Despite its impressive size, Uranus is much less massive than Jupiter or Saturn, with a mass that is only about 14.5 times that of Earth. Uranus is composed primarily of ices including water ice, ammonia ice, and methane ice, giving it a unique bluish-green color. These ices are not like the ice we find on Earth. They are much more exotic and complex. The extreme pressures and temperatures deep within Uranus create exotic forms of ice that behave very differently than the ice we know, adding to the planet's mysterious nature. Unlike the rocky terrestrial planets like Earth and Mars, Uranus is classified as an ice giant. This classification stems from its composition, which is dominated by these icy materials rather than rock or gas. Deep beneath Uranus's thick atmosphere lies a vast, slushy mantle. This mantle is not an ocean in the traditional sense, but rather a hot, dense fluid composed of water, ammonia, and methane. The extreme pressure and temperature conditions within the mantle prevent these materials from existing as solids. At the heart of Uranus, scientists believe there may be a small rocky core. However, this core is likely not distinct like Earth's, but rather dissolved and mixed with the surrounding icy mantle. Uranus's atmosphere, while composed primarily of hydrogen and helium like Jupiter and Saturn, holds its own unique characteristics. It is the coldest planetary atmosphere in our solar system, with temperatures plummeting to minus 371 degrees Fahrenheit or minus 224 degrees Celsius. The pale blue-green color of Uranus comes from the presence of methane in its upper atmosphere. Methane absorbs red light from the sun, giving Uranus its distinctive hue. Uranus's atmosphere is also surprisingly bland compared to the swirling storms and colorful bands seen on Jupiter and Saturn. However, this does not mean Uranus is a calm and peaceful world. Observations have revealed faint cloud features and even massive storms raging in its atmosphere. Faint rings of Uranus. Like all the giant planets in our solar system, Uranus possesses a system of rings. However, unlike Saturn's bright and prominent rings, Uranus's rings are dark and faint, making them difficult to observe from Earth. Uranus's rings are composed of dust and small particles, likely the remnants of shattered moons or comets. The particles in Uranus's rings are incredibly dark, reflecting very little sunlight. This is part of the reason why they were not discovered until 1977, when astronomers observed Uranus passing in front of a distant star. There are 13 known rings of Uranus, each with its own unique characteristics and composition. Some rings are narrow and well-defined, while others are broad and diffuse. The rings of Uranus continue to be a subject of study, with each new observation revealing more about their composition and origin. Miranda, a moon with a chaotic past. Uranus has 27 known moons, each with its own story to tell. One of the most intriguing is Miranda, a small moon with a surface unlike anything else in our solar system. Miranda is covered in a bizarre mixture of terrains, including towering cliffs, deep canyons, and strange grooved features. This chaotic landscape suggests a violent and tumultuous past. Scientists believe that Miranda may have been shattered multiple times by impacts, only to be pulled back together by its own gravity. This process of disruption and reassembly could explain its jumbled and diverse surface features. Ariel, the brightest moon of Uranus. Ariel is another of Uranus's notable moons. It is the brightest of Uranus's moons and has a relatively young surface with few impact craters. This suggests that Ariel has experienced some form of geological activity in its past, resurfacing its terrain. Ariel's surface is covered in valleys, ridges, and what appear to be ancient flow features. These features indicate that Ariel may have once had a subsurface ocean or at least regions of internal melting. The exact nature of Ariel's past activity remains a mystery. However, its bright surface and intriguing features make it a prime target for future exploration. Umbriel, the dark moon. In stark contrast to Ariel's brightness, Umbriel is the darkest of Uranus's large moons. Its surface is ancient and heavily cratered, indicating a lack of recent geological activity. Umbriel's dark surface reflects very little sunlight, making it difficult to study from Earth. Scientists believe its surface may be composed of dark, carbon-rich materials that have been darkened further by radiation from Uranus's magnetosphere. One of the most intriguing features on Umbriel is a bright ring at the bottom of one of its craters. The composition of this ring remains unknown, but it suggests that Umbriel may have experienced some form of internal activity in its distant past. Titania and Oberon, the two largest moons. Titania and Oberon are the two largest moons of Uranus. Titania, the larger of the two, is covered in impact craters, canyons, and fault lines. It is thought to be composed of about half rock and half ice. Oberon, the outermost of Uranus's large moons, is similarly ancient and heavily cratered. Its surface is darker than Titania's and shows evidence of past cryovolcanic activity, where water or other volatile materials may have erupted onto its surface. Both Titania and Oberon are tidally locked to Uranus, meaning they always show the same face to the planet as they orbit. Their large size and diverse surface features make them valuable targets for future missions to the Uranian system. Voyager 2, a fleeting glance. Our most detailed glimpse of Uranus came from NASA's Voyager 2 spacecraft, which flew past the planet in 1986. Voyager 2's encounter with Uranus was brief but groundbreaking. The spacecraft revolutionized our understanding of this distant ice giant. Voyager 2 captured stunning images of Uranus's pale blue-green atmosphere, revealing faint cloud bands and a surprisingly dynamic atmosphere. The spacecraft also discovered 10 new moons, confirming the existence of Uranus's faint ring system. Voyager 2's observations of Uranus's moons were equally groundbreaking. The spacecraft revealed the chaotic surface of Miranda, the bright young surface of Ariel, and the dark, ancient surface of Umbriel. Voyager 2's data continues to be studied today, providing valuable insights into the Uranian system. Unlocking the secrets of Uranus. Uranus, the tilted ice giant, remains one of the most enigmatic planets in our solar system. Its pale blue color and mysterious atmosphere have fascinated astronomers for centuries. Its unusual axial tilt, faint rings, and diverse collection of moons continue to intrigue and puzzle scientists. Each moon has its own unique features, adding to the complexity of this distant world. Further exploration of Uranus is crucial to unraveling the mysteries of its formation, evolution, and the processes that have shaped its unique characteristics. Understanding these processes can provide insights into the early solar system. Future missions could study Uranus's atmosphere in more detail, revealing the composition and dynamics of its thick, icy clouds. map its gravitational and magnetic fields, which could uncover hidden layers within the planet and offer clues about its internal structure, and even explore its icy moons in search of signs of past or present life. These moons, with their potential subsurface oceans, are prime candidates for astrobiological studies. By studying Uranus, we can gain a deeper understanding of the diversity and evolution of planetary systems, not just in our own solar system, but also around other stars. This knowledge can help us comprehend the vast array of exoplanets discovered in recent years. Uranus stands as a testament to the vastness and wonder of the cosmos, beckoning us to explore its icy depths and unlock its hidden secrets. The journey to Uranus is not just about the planet itself, but about our quest to understand the universe.